right. Good morning, everyone. Good morning. Hope everyone's doing great and everyone is all right. So hope you had a great weekend. Today we're going to look at 7.3 probability and odds. So some of these terms you already been exposed to. I think it was might have been 7.1, where I introduced experiment and all the good stuff like that. So some of them just a rehashing or reviewing terms. So we'll go ahead and get into those though. And probabilities, first term that we have is that's the likelihood of the occurrence of a particular event. It is between 0 and 1, 0% and 1 being representative of 100%. So for those just coming in, said a few minutes ago that some of these terms we've already talked about and discussed, but just reviewing them as we get into probability. All right, so experiment is any occurrence for which the outcome is uncertain. So an example, that's flipping a coin. Sample space is the set of all possible outcomes of an experiment. Normally we use S to represent our sample space. Sample space for flipping a coin will be heads and tails. Those are all of your possible outcomes when it comes to flipping a coin. Hold on to experiment. All right, event is any collection of outcomes from the sample space. So we use normally use any capital letter for your event, other than S, of course, because S we use for sample space. Okay, so my coin landing tails face up, my event would be, tails. All right, actually computing the probability. If I want to know the probability of an event, we normally notate that with P parentheses, whatever that event label that we called. In this case, let's say we said E. So the probability of event E occurring. We take the number of the outcomes in your event and place it over the number of outcomes in the sample space. So in parentheses, E represents the number of outcomes in the event. in parentheses S represent number of outcomes in your sample space. All right, so if I want to lean on those initial examples I gave when it comes to flipping a coin, I want to know the probability of laying the tails face up. I look at my sample space. The number of outcomes in my sample space is 2, because I have heads and tails. Then I look at the number of outcomes in my event. The number of outcomes in my event is just 1, which is tails. So then once I have both of those pieces, I place the number of outcomes in my event over the number of outcomes in my sample space. That'll be 1/2 as my probability. You know, you convert to a decimal to 50% chance. All right, that'll be good. All right, so let's look at this first real example. A die is rolled once, find the probability of rolling a 3. So we want to know the probability of rolling a 3. First thing we want to do is establish our sample space. So this would be the steps that you take for all of the probability problems. You always want to establish your sample space first. It's always the easiest way to go about doing so. Examine how many possibilities and what are all of the possibilities that you may have when it comes to this probability or this experiment. So when it comes to a regular die, you have 6 sides and you have these pips that represent, each number on each side. So, 1, 2, 3, 4, 5, 6. And so you have 6 outcomes in your sample space. So that's why this number is 6. And so one thing I always try to emphasize is don't confuse this 6 and this 6 and say that they have to be the same. So if this is 1, 2, 3, 4, 5 triangle, the number of outcomes in my sample space is still 6. Okay, so that's not 6 because that one is 6. It's 6 because there are 6 outcomes. This is 6 because there are 6 outcomes, not because this number ended in 6. So just want to make sure that we didn't think that was the case. All right. So from there, you're going to establish your event. My event is rolling a 3. Says how many outcomes or how many 3s are there? There's only 1. So the number of my event is 1. And then I can calculate the probability that's 1/6. Got a 1 out of 6 chance of rolling a 3. All right, let's look at another one. Still dealing with the same example or the same experiment, talking about rolling a die. What's the probability of rolling an even number? So we already know that our sample space is six. There's six numbers. We talk about rolling this die, regular sided die. How many even numbers are part of that sample space? There are three of them, 2, 4, and 6. So the number of my event is 3. Now that I have those two numbers, I place the 3 over 6, and that reduces down to 1/2. All right. And then the next one, what's the probability of rolling a number greater than 10? So when we look at our sample space, it's numbers 1 through 6. There is not a number that's greater than 6. So of course, there's no number greater than 10. So the number of outcomes in your sample space that are greater than 10 is 0. And a circle with a slash through it is considered the null set. So if you see that symbol, that's what that represents. And so, like I said, no number in the sample space is greater than 10. So that would be the null set, which represents 0 for the number of outcomes in that event. And then place 0 over 6. The probability of getting a number that's greater than 10 is 0. All right. Another example dealing with dice. Everybody okay with this page before I go to the next page? All right. So one of the examples or one of the problems I saw in weapon science dealing with two dice, two six-sided dice. So when you look at two six-sided dice are tossed, you want to do examine, as always, you want to example your sample space and say, okay, how many outcomes are there? You may not want to list out every single outcome, but you do want to examine how many outcomes are there if you were to roll two dice, two fair-sided dice. So when you talk about two fair-sided dice, let's say you have one, call one die one, call the other one die two. So exploring all of the possible outcomes, you're talking about when die one is one, die two is one, die one is one, die two is two. 1, 3, 1, 4, 1, 5, 1, 6. Then possibilities when die one is 2. And then you go down to this with die 2, die 1 is 3, go down to this with die 3. So you don't want to write all of those out. But what we can do is lean on the fundamental counting principle, knowing that when it comes to die 1, if I have 6 outcomes for die 1, and then 6 outcomes for die 2, and I only can choose one in each case, I can just multiply those together, and that will let me know how many outcomes I have in total. So there are 36 total outcomes when it comes to rolling two six-sided dice. Okay, so total number of outcomes is 36. Right. So B, what is the probability of rolling a 7? All right, so we know our bottom number in our probability, bottom number of our fraction is 36, because that's our sample space. Now we need to explore all possible ways of getting a 7. There we go. Yep. So when I go down here to the purple, I want to know how many different ways can I get a 7? So when die 1 is 1, we know the extent of the numbers that we have is 1 through 6. So if die 1 is 1, and die 2 is 6, 1 plus 6 is 7. All right, so that gives me 7. Now when die 1 is 2 and die 2 is 5, that gives me 7. When die 1 is 3 and die 2 is 4, that gives me 7. Now, die 1 being 3 and die 2 being 4 is different from die 1 being 4 and die 2 being 3. So then we have to explore those options. So we got 4, 3, then 5, 2, and 6, 1. These are all of the outcomes for when our die, when we roll 2 dice, they add up to give us 7. So notice we have 6 outcomes that will give us 7. So that's the number of my event. So now that I have the number of my event and the number of my sample space, I can go ahead and place that 6 over the 36, and that reduces down to 1 over 6. So I have a 1 out of 6 chance of rolling the 7. All right, questions on that before we look at, I think I got C down here, yep. All right. So C, what is the probability of rolling 2 1s? In other words, snake eyes. So there's only one way of getting snake eyes or 2 1s. That's when die 1 is 1 and die 2 is 1. Outside of that, there's no other combination. So once again, our sample space is 36. Rolling a snake eyes is just 1. There's only one way of doing that. So our event number is 1. So that's 1 over 36. That's your probability. All right. Are you good with that before we go back to the other page of notes? All right, they do. Yeah, let's talk about cards. So let's look at the standard 52 card deck. Pretty sure I saw y'all problem dealing with cards. So we'll talk about it. So we have 4 suits. We never dealt with cards before. And the standard means that there are no jokers. So we have 4 suits: spades, clubs, hearts, and diamonds. 2 of them are black, 2 of them are red. So spades and clubs are red. I mean, spades and clubs are black, excuse me, and the hearts and diamonds are red. 13 cards in each suit. 13 times 4 is 52. So we have 3 face cards and 10 non-face cards. The face cards are your king, queen, and jack. And non-face are the ace, 2 through 10. All right. So if you dealt 1 card from a standard 52 card, you dealt the king. So we know there are 52 cards in the deck. You don't have to write out all 52 cards or write out all 52 options. But we know there are 52 cards in the deck. And then you say, well, how many kings are there in the deck? Well, there are 4 kings because for each suit, you have a king. So take that 4, place it over 52. That reduces down to 1 over 13. So you have a 1 out of 13 chance of getting a king. All right. Next one was the probability of getting a heart. All right. 13 hearts. Place that 13 over 52. That's 1/4 when you reduce it all the way down. We're at 13 cards per suit for each suit. And then the last one out of this example, King of Hearts. Once again, there's 52 cards in the deck. There's only one King of Hearts, though. One King of Hearts. And so you place that 1 over 52. And that's your probability. You have a 1 out of 52 chance of actually getting the King of Hearts. All right. Next thing in the section are odds. So the probability of odds, you want to calculate the odds in favor of an event. You take the probability of your event and place it over the event not happening. We'll talk about how to calculate that in a second. Probability of your event, probably, or let me say it like this, the odds against your event is the probability of your event not occurring or the probability of the event occurring. All right, you roll a single die, find the odds in favor of rolling a two, find the odds against rolling a two. All right, so if your event is rolling a two, we have 6 options when it comes to rolling a die, a single die, normal sided or normal die, normal fair die. So, this number is 1 through 6. My event of rolling a two, there's only 1, 2. So the number of outcomes in my event is just 1. And so the probability of rolling a two is 1 over 6. All right. So the probability of not my event, or the probability of my event not occurring, or probability of not my event. The way we would do that, and we're going to talk more about complements in the next class or in the next section. I'm not sure why they did it in that order. Normally we talk about complements first before we go into odds. But anyway, so but this is a new book, so that's how they have it structured. The way we can do that is subtract my probability of my event from 1. So in other words, if I were to do this, so the probability of my event not occurring, I would do 1 minus the probability of my event. And that's what I did down here. Thought I could do it a little better. It up later. So 1 minus 1 over 6. That 1 turns into 6 over 6, whatever that denominator is, you take it to that over itself. So it's 6 over 6. And that's minus 1 over 6, which is 5 over 6. That's called a complement. All right. So to calculate odds in favor, take the probability of your event, place it over the probability of your event not occurring. So that's 1 over 6 divided by 5 over 6. Notice that those 6's will cancel because whenever you divide them by a fraction, you multiply them by the reciprocal. So it's 1/6 times 6/5. 6 is canceled, leaving you with 1/5. All right. So odds in favor of rolling a 2 are 1 to 5. Or you can use a colon. It's 1:5. All right. Odds against. Same process, just inverted or flipped. So you got the probability of your event not occurring over the probability of event occurring. So it's 5/6 over 1/6, which we already talked about how those sixes will cancel and leave you with just 5/1. And so just here, if you already calculated one, if you flip it, and that's the calculation of the other. So odds in favor versus odds against are just that fraction inverted. So the odds against rolling a 2 are 5/1. Mhm. So holding on to that last example. All right. The winner of a raffle will receive a new SUV. If 500 raffle tickets were sold and you purchased 10 tickets, what are the odds against your winning the car? All right. So first of all, we look at the probability of my event occurring. We have 500 tickets altogether, so that's my sample space. And you purchased 10 tickets, so that's my event. Me winning will be based on those 10 tickets, one of those 10 tickets being picked. So the probability of me winning or my event occurring in this case is 10/500, and that reduces down to 1/50. And then, like I mentioned in the last example, the probability of my event not occurring, in other words, the probability of me not winning would be 1 minus the 150. So that 1 turns to 50/50, 50 minus 1 up top would be 49/50. All right. So the odds against, you take that probability of event not occurring over, place that over the probability of event actually occurring. So it's at 49 over 50. And we place that over the 1 over 50. Those 50s will cancel for us, giving us 49 over 1. All right. So concluding statement, the odds against winning the SUV are 49 to 1. All right. Last one, or last thing I should say. If we want to convert odds to probability. So if the odds in favor of event E are A to B, then the probability of the event is given by A over A plus B. All right. So the odds in favor of a particular horse winning a race is 2 to 5. What is the probability that this horse will win the race? All right. So this says odds in favor. We have 2 to 5. That means A is 2 and B is 5. The one that comes first is always A. The second one is always B. So A is 2, B is 5, and then we plug it into the formula of A over A plus B. That'll be 2 over 2 plus 5, and that means the probability is 2 over 7. Well, and Web Assign will let you know if they want that as a decimal or percentage or not. But yep, 2 over 7 is probably or 2 out of 7. All right, questions, concerns, comments, anything, anybody? I believe that's our last problem out of this section. Yep. That's it for 7-3. Next class will come back and knock out 7-4, and then go from there. But like I said, any questions, concerns, comments before we close out today? Everybody good? All right, y'all have a great day. Take care.